Everyone, it's Mrs. Carnahan. So I do want to warn you, today's notes might be a little bit longer because this is such a big section, but it isn't split into 2 days still. So we're going to talk about trigonometry, and you might have been having some trouble with 30, 60, 90, and 45, 45, 90, and all the other methods of solving right triangles, but I find that a lot of students trigonometry seems to stick with people a little bit better because what it will help with is solving any type of right triangle. And it will help us find side lengths. It also helps us find angle measures. So this will be for any angle measures in a right triangle, not just those special ones that we've talked about. Okay, so we're going to talk about creating trig ratios using the sides and then also using the trig ratios to solve for the sides. So first, what is trigonometry? Because this is a big word. Trigonometry is the study of triangle measurement. And we're going to talk specifically about right triangle trigonometry. So just the study of right triangles. A trig ratio is the ratio of the lengths of two sides of a right, there's the bell again, of a right triangle, okay? So these are our three trig ratios. We have the sine ratio, cosine ratio, and the tangent ratio. Now, these have to do with comparing specific sides. And we're comparing them in terms of an angle. So down here, I'm going to look at just angle B. So the sine, cosine, tangent ratio will change based on which angle I'm starting with. It's either going to be angle A or angle B, because angle C is the right angle. So we don't do SOHCAHTOA based on the right angle. Sorry, I'm talking ahead, SOHCAHTOA. We don't use sine, cosine, tangent for angle C, but just for the two non-right angles. So I'm just going to do it from B. Now, the sine ratio is the opposite side. So opposite of B is side B. So this is the opposite side. Now, the hypotenuse is your C, right? C side. So this is the hypotenuse. And then the one right next to it, the last side, is the adjacent side. So we call it the adjacent side. Now we kind of worked ahead because that's going to be at the bottom of your notes, but we need them in order to set up our ratios here. So the sine ratio is the ratio of the opposite side, because these are all, again, looking up above, it's the ratio of the lengths of two sides. So the sine ratio is the opposite side over the hypotenuse, which I made red here. Okay, so sine of that angle B, and this is from angle B, right? From angle B it would be B over A. And again, opposite and adjacent change based on which angle you're looking from. If I was looking from angle A, my opposite side would be what the adjacent is for angle B. So those flip, the hypotenuse is always the same. Now, the cosine ratio is the ratio of the adjacent side to the hypotenuse. So adjacent over hypotenuse. Okay, and then finally, the other ratio for tangent is the opposite side. And I know it sounds like another language right now, but I promise it'll make more sense once we start plugging in a calculator and all that. So opposite over adjacent. Okay, now one way to abbreviate those ratios and make it a little easier to remember is SOHCAHTOA. So we have S, which will stand for the sine ratio, is equal to the opposite over hypotenuse. So that's pronounced so. So if you look at SOHCAHTOA, it's S-O-H. So I usually set it up as S-O over H. And then the cosine is the adjacent, so ka over H. So that's pronounced ka. And then toa So for tangent, it's opposite over adjacent. Oops, that was supposed to be blue. Okay, so I usually write it out that way, but you can just write it out SOHCAHTOA like it's written on the left side. And that's just to help you remember. So you'll hear me refer to it as SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. And that just helps you pronounce and figure out, okay, it's OH, ka, it's AH, toa, it's O over A. Okay? So it's just kind of to help organize which one's which. Now, theta is a variable. So it's a variable that we use for angles. And now this is a Greek letter, so you can look it up and see what it looks like. But it looks like this. It looks like an O with a line through it. That was terrible. So I usually draw it like that. If you look it up, it looks probably something like that with a little squiggle in the middle, almost like the similar symbol in the middle. But that's theta. It's a variable. It's a Greek letter. It's just, something we use for angles. It's pretty common. Okay, so I'm going to show you again labeling the hypotenuse, adjacent, and opposite side using theta as one of my angles. So there's my theta. Again, it looks like an O with a squiggle through it. So labeling based on that angles, my opposite side is across from that angle. So I think I used green for opposite. And usually I just do OPP. And then my adjacent side's the one that's not the hypotenuse. It might help to even start with the hypotenuse so that you can get that one out of the way. Across from the right angle is your hypotenuse. And I usually just abbreviate these. Okay? So now we're going to talk about first just setting up the ratio. So we're going to label the sides according to that specific angle, and then we'll also talk about how to write the ratio. Okay? So from angle S, here's angle S. I'm going to put a little theta where S is, because that's angle S. I want to label, so my opposite side from angle S is the 8. So that's the opposite side. The hypotenuse, maybe you want to start with that, is the one across from the right angle. And then finally, the adjacent side is the one right next to it, so the 15. Okay, so that's labeling it, just labeling the triangle. So let's do B as well. Now we're going from angle P, so I'm going to put my theta where angle P is. My opposite side now is the 15. It's across from the angle. My hypotenuse is still the same. It's still across from the right angle. That's always there. And now my adjacent side is the 8. So notice in these how the opposite and adjacent flip because I flipped my angle. Okay, so that is important. Now we're going to do that same thing again. We're going to label every single time. I might not use different colors here. I'm probably just going to stick with blue or green. So we want to express each ratio as a simplified fraction and as a decimal to the nearest hundredth. So you can just divide these out in your calculator. I'm just going to give you them after we set them up. So we're going to start with angle L because that's what each one says. It says sine, and then it put the angle next to it, L. That tells you the angle. The angle always goes with the trig ratio. And sine's abbreviated to sin, cosine is cos, and tangent is tan. So remember, if we write out SOHCAHTOA, our sine is opposite over hypotenuse. So I'm going to label, here's my opposite side, opposite the angle it's across. Adjacent, is right next to it. And my hypotenuse is always across from my right angle. So sine is opposite over hypotenuse. So the opposite side was 12. So I'm going to take 12 over the hypotenuse, h, so 37. I'm going to divide that. That's your fraction. You can't simplify it, so we'll leave it like that. If you divide it, we get 0.32. Okay? Now, cosine is adjacent over hypotenuse. So I'm going to take the adjacent side, 35, over 37. Sorry, that's just supposed to be for cosine. I should probably just zoom in a little here, make it easier. So 35 over 37. When I divide those, I get 0.92. Usually we'll leave it as a fraction, but that's how you would get a decimal. Now the last one is tangent, and so that is opposite over adjacent. So opposite side is 12 over my adjacent side, which is 35. Again, cannot be simplified, but if it could, I would. And that would be 0.34 if I divide those numbers. Okay, so that's just how you write the ratio. Okay, eventually we're going to use this to start solving for sides. So these are what our equations are going to look like when we start solving for the sides. When I want to solve this first one for x, notice how on all of these, the angle is with the trig function. The angle will always be with sine, cosine, or tangent. Okay, so now when I solve, the 15's in the denominator. I'm going to multiply both sides by 15. And I'm going to have 15 sine 23 equals x. Now, how are we actually going to find this number? I'm going to show you in the calculator. So if you can get your calculator out. Oops. So first thing you want to do is go to mode. Okay, now this is an app called Calculate 84. So if you don't have a calculator, you can use this app. First thing you need to do is go to mode and change your calculator from radians to degrees. Press enter on it and it should be highlighted like mine. Now you'll quit, second mode. Now when I type in 15 sine, you'll notice in the middle sin, cos, tan, we want to pick sin for sine, and then 23 is the angle. Now we change it to degree because all of our angles are in degrees. So that's why you want to always make sure your calculator's in degrees. If you did not get what I got, it's probably because your calculator's not in degrees. So I got 5.9. Okay, so going back here, I got x is 5.9. Okay, so sine, cosine, tangent, those get plugged in your calculator to get the number. Okay, in B, I'm going to multiply both sides by 5. So that I get W equals 5 cosine 74. So I'm going to go back to the calculator to show you one more time. And then from here on out, I'm just going to tell you what I get. So I have 5 cosine, so you can hit the cos button, and then 74. Now you shouldn't have to switch your calculator to degrees again. Once it's on there, it should be there unless you reset your calculator. So here I got 1.4 for W. Oops. Okay. Now in this last one, notice how y is in the denominator this time. So what I'm going to do is what I call the switcheroo method. I'm going to switch the y with tan 60. So it's going to be 3 over tan 60. Otherwise, I could have multiplied both sides by y, but then I'd have to divide by tan 60. So I'm just kind of skipping that double step, and I'm flipping where y and tan 60 is. So this time I'm going to take 3 divided by tan 60. So it'd be 3 divided by, and then tan 60. Enter. I got 1.7. Okay, so notice when the variables in the numerator, we multiply both sides by what's in the denominator. When the variables in the denominator, we did the switcheroo method. I call it switcheroo because it's kind of funny. Where we switch the variable with the function, the tan 60. Okay, so we end up dividing. All right, so now how are we going to use these to solve these triangles? So we're just going to do a few examples here. First thing we need to always do when we're using SOHCAHTOA, and I'm going to write SOHCAHTOA again. You should write it on your paper for reference. Every time we're doing these, write it at the top. First thing I'm going to do is label my triangle based on the angle I'm given. So in this first example, I'm given 54. So across from 54 is my opposite side. In this case, that's x. Now, adjacent is right next to it. And then finally, your hypotenuse is across from the right angle. Now, the one I'm given is the opposite side and the adjacent side. So then I determine which function I'm going to use. Opposite over adjacent would be tangent, okay, is the one that involves both the opposite and adjacent. So I'm going to take tangent of the angle 54 equals my opposite side x over my adjacent side 5. Then, because my variable is in the numerator, I'm going to multiply both sides by 5. So we'd have 5 tan 54. You'd plug that in your calculator just as it is. And just so you can check my work, I got x equals 6.88. It did say round to the nearest hundredth, so that's 2 decimal places. There's a decimal there, 6.88. Okay? Now, for the next one, again, label your sides based on the angle you're given. So I'm given the angle's 27. So across from 27 is the 5. That's my opposite side. My adjacent side in this one's the x because I'm not given the hypotenuse. The hypotenuse is over here and it's blank. So again, I'm using tangent because I have the opposite and the adjacent side. So I'm going to do tangent of the angle, so 27, equals opposite, which is 5, over adjacent, which is x. In this case, my variable's in the denominator. So I'm going to switcheroo, switch where the x and the tan 27 are. I'm going to rewrite this a little lower. So x equals 5 divided by tan 27. So in your calculator, you type in 5 divided by tan 27. I got 9.81. Okay? Now, last one. The triangle's labeled. I know it's a story problem, but everything's labeled. In this one, my angle down here is 7. So I want to label my sides. The opposite one would be y. And then in this one, I have the hypotenuse, which would be 5. And I don't have the adjacent side. There's nothing there, so I'm not going to use it. I'm using opposite and hypotenuse. Now, looking back over here, sine is opposite over hypotenuse. So that's the one I want to use, is the sine function. So I'm going to do sine, which is sin, and then remember the angle always goes with the function, so sine 7 equals opposite y over hypotenuse 5. So opposite over hypotenuse. Now I can solve this equation by multiplying both sides by 5. So what you would type in the calculator is 5 sine 7. And when you plug that in, you should get 7.3 inches. Okay, so it's just a matter of using the SOHCAHTOA to help set up your equation so that you can solve for the missing side. Okay, we'll do some more practice on this, so don't worry if you don't get it quite yet, but go ahead and try those summary problems.